2.5. Our objective today is to write and graph direct variation equations. Direct variation is when two quantities are related by a simple equation, y equals a times x. Kind of like just y equals slope times x, no y-intercept other than 0, always goes through the origin. That number a is called the constant of variation. And this again is called direct variation because to get one number, you multiply. To get from one number to the other, you just multiply by a specific number. So we want to write and graph a direct variation equation that has -4, 8 as a solution. The setup for something like this, since we know it's direct variation, we can start by saying y equals a times x. We just have to solve for a. We're given some information. We know that at some point on this line, y equals 8 and x equals -4. Once you've written that, solving for a is one step away. So we can get our solution, y equals -2x. Of course, we know how to graph that. Y-intercept is 0 up to over 1. Again, direct variation, the line always goes through 0, 0, because the y-intercept is always 0. That's it for direct variation. Now we're going to look at a couple of applications. But first, you can pause the video and try these on your own, or you can do these later. Go ahead and pause the video and try to decipher what's going on in this problem. As you may have noticed, the diameter varies directly with the time. So for part A, we should be able to write something like diameter equals a times t. We don't know what a is yet, except we can figure it out just like we did in example 1. From the picture, we know that when the diameter is 0.75, t is 12. So we can solve for a. And we get 0.0625 with a calculator, of course. So our equation becomes d equals 0.0625 t. Part B is just a slight extension on part A. We're going to use the equation we just got to predict the diameter after 20 minutes. So we plug 20 into that and see what we end up getting. Turns out to be 1.25. And we've got to put the right units or we didn't do it right. This diameter is given in inches. So we say 1.25 inches. And that's it for this one. So as an example of where a word problem is not asking you to do too much, you just have to pay attention to what it's asking you to do. Sometimes that means read it a couple times. One more word problem. Go ahead and pause the video and try to see what's going on here before we talk about it. If there is a direct variation going on here, which is what we're trying to find out, that means our body length and our tooth length should vary directly. There should be some a that we can plug in. Now if I choose a couple of values, like if I try plugging in the 215 equals a times 1.8, or if I do it with any other one of these pairs of numbers, I'll notice that every single time I get a number real close to 120. Not exactly 120, but no matter what two pairs of numbers, or no matter what pair of numbers I use, I always get something real close to 120. That makes a good case that tooth length and body length vary directly. My formula would be something like b equals 120 t. It's not asking us to plug anything in, so we're done at this point. At this point, you can pause the video and try these on your own. Other than that, we are done with this lesson.